Welcome to Compound Interest. It's section 8.2 in your book, and let's get right to it with the objectives. We've got just a few objectives. Mostly they have to do with formulas and when to use them and how to use them. There are two compound interest formulas I'm going to ask you to memorize. At least have them down on what you might call a cheat sheet. We're also going to have one that's very similar to the compound interest formulas, and it's called present value. This is working backwards, and we'll get to that in time. Also, to wrap things up, we're going to talk about computing effective annual yield. And a quick note on that is, remember we talked about simple interest last time. What this means is, if you get a certain result from using compounding interest, what would you have to have in the rate of a simple interest to get the same result? So here we go, and I'm going to clear this. There we go. All right. Here's one formula, and you don't need to bother with this one. We're going to have a more comprehensive one. First of all, a couple of things about A. Oops. There we go. I guess I must have turned off the pen. There we go. We're back in business. Okay. So don't bother memorizing this formula right here. We've got a better one. But we can pick up some concepts. This A is the future value. P is the present value, the money you have invested. 1 is just 1. R is the annual rate, and T is the time in years. Make sure that this is the annual rate, and this is T is in years. If you see something in terms of months, you must convert that to years by dividing by 12. So we've got an example here, and I'm going to use the formulas I've got here. The one they mentioned there was P times 1 plus R to the T power. Real simple. Don't memorize that one, but we've got a similar one that will take care of all these examples and much more. You first want to find the amount, and then you're going to find the interest. Once you've got the amount, the interest is easy. So the principal is $2,000. It's from up here. The annual rate is 6%, but you want to use 0.06 because at some point you'll want to use your calculator. Notice that T is already in 3 years, so 3 is fine. Put those into that formula, and there's the principal, there's our 1, there's our annual rate, and this is the number of years. Just put those in your calculator. Good practice for using your calculator. Make sure you can get $23,882. $2,382.03. If you have trouble, stop by the office and we'll get your calculator skills up to date. Next, this was the amount we got right here. And the second part says, what's the interest? Well, we started with $2,000, so if we want the interest, take the amount, subtract the original amount, and there's your interest. Now here's the formula that I want you to remember, or to write down and be able to use fluently. There we go. Okay, here's your amount that you have at the end of the time period, also called future value or maturity value. P is the principal, also called the present value. that's how much is being invested. 1 is 1, R is the annual rate, N is the number of times per year that the compounding actually occurs. Take special note that this N also shows up in the exponent. Again, once more, T is in years. If you see your question is in months, convert it to years. And last of all, because NT is your exponent, make sure that all of the N times T, whatever that product is used as the exponent. If you only do this on your calculator and you have N and then times T, it's not going to work out properly. Now, if you've got one of the TI-84 pluses or plus CEs and you're in the exponent mode up here, you can just put N times T and you're in fine shape. If you see earlier you're having trouble, check with me or play with this, check with Google, get it straight before you go too far. So A is the future value, and the principal P is the present value. Remember, this is also called just straight up the amount. It's also called the maturity value. Maturity value. And the principal is called the present value as well. Here we've got an example. We've got $7,500. Where's my cursor? There we go. $7,500. That'll be the principal because that was deposited. You have a rate of 6%. We're going to assume that's the annual rate because that's typically the way it's depicted. Now, you have also a compounding monthly. How much money will you have after 5 years? So first of all, write down your formula. Good practice because you probably don't have this memorized yet. And there's the formula. You want the amount. So just put the numbers in. You're investing $7,500. So that goes into P. 1 is 1. R is 0.06. N is the number of times per year that's compounded. This is monthly, so that's 12 times. So 12 goes here. Remember, the 12 goes here, and it goes in the exponent as well. Times the number of years. Number of years, 5 years. So there's the expression you need. And your next challenge really is, can you put that all in your calculator and get the proper result? So you can see down below here, because I haven't split these up, that's the result for the amount. This is how you do the calculation using that formula. Now, the second part is find the interest after 5 years. Well, if we started with $7,500 and we ended up with $10,116.38, subtract those, and that's how much interest was added to the $7,500. In particular, $2,616.38. Just subtract those two. Having trouble here. Okay, there's the amount we got. This is the invested amount, so this is the interest. Continuous compounding. Now this is a slight bit different, but not too different. These are the two formulas you need to know. This for the regular compounding here, and this is for the continuous compounding. R is the same, T is the same, P is the same. The only difference is that over here we have an n, and here we don't need it because it's continuous compounding. You could almost say that infinite compounding. And all you need to do is put the values into the appropriate formula, and you can get the correct answer. A little bit of practice, you'll be good with getting the right formula and also putting it in the equation the right way and getting your calculator to work for you. So remember, n is how many compounding periods you have per year. For continuous compounding, you don't need the n because n is effectively infinite, or nearly so. Here's an example. First of all, when I read through it, I see some important parts. There's a principal I'm going to use. Here's a t I'm going to use. You have two accounts. The first one is 7% compounded monthly. As soon as you see that compounded monthly, you know that the first one is going to use this formula. So put the numbers in. You got 8,000, 1 plus 7% for the first one, so 0.07. It's compounded monthly, so 12 goes here. Immediately put a 12 up there. How many years? Well, it says nothing, so we're going to take it as, 6 years. 12 times 6, there we go. And you can calculate that. See what we get with the 7%. How about the second one? Well, that's compounding continuously. That's a different formula. Not totally different, but it looks different. There's the formula. 8,000 again, start the same way. But now you're multiplying it times e. Remember, and just a note, e equals 2.718 ... And there's a special key on your calculator to give you the exact, the calculator approximation for e. And e has an exponent of r times t. R is 0.07. T is 6. And then you can compare those two. Let's see what happens. The first account, using the monthly compounding at 7%, you get $12,160.84. For the second one, continuous compounding at 6.85%, you get $12,066.60. And that means the better investment was the 7% monthly compounding. Next, present value. Well, this should look a little bit familiar, and it looks like someone messed up the formula. But actually, this started out as A equals P, 1 plus R over N to the N T. Now, what we wanted was this. So if I divide both sides by that, this is what I get. So if we want this amount of money, this number of years from now, and it's compounded this often per year, at that rate, this is how much money I'll have to put in right now to end up with that amount. We've got an example coming up, so fear not. So let's see how we calculate present value. Remember the formula. How much money should be invested in an account today or deposited, getting 6% compounded monthly, so you'll end up with $20,000 in 5 years. So first of all, the formula, P equals A over 1 plus R over N to the NT. Now let's put those numbers in. You want to end up with $20,000. On the bottom, you'll have 1 plus, the rate is 6%, so it'll be 0.06. It's compounded monthly, so it'll be a 12 here. Immediately put a 12 up there, and it's 5 years. And all you need to do is put this successfully into your calculator, and you'll get the answer. There are the pieces. There they are put in the formula. A little bit nicer writing, but it's still the same thing. And you end up with 14,000 and so on after 5 years. Invest that today, and 5 years from now you'll have $20,000 at 6% compounded monthly. And the last topic is effective annual yield. So a couple of notes. So imagine you have compound interest working and you get a certain amount. You start with a certain P up here and you end up with A at a certain rate. Now, what if you had simple interest? What would the rate have to be so you end up with the same amount? And that's what effective rate means. You've got compound interest? Fantastic. What if you needed to put it in a simple interest account but end up with the same amount? What kind of rate would you need? Here's how you work it. Now think about 1 year at a time. That's the key. 1 year. So we're going to find the future value after 1 year, and then we're going to backtrack to get the effective annual yield. So first of all, what's the future value? Well, we've got compounding monthly. So A equals, that's the future value, P, 1 plus R over N to the NT. The more times you see this, the better off you are. P, you're investing $4,000. There's our 1. We've got 8% interest. Compounding monthly, so a 12 goes there, and a 12 goes there, and that's times 1 for 1 year. So this amounts to $4,332 even. Now, what we're going to do is we're going to put in the simple interest formula. Remember what that was? There's a simple interest formula. You have 432. You're putting, $4,000 in. 1 plus. Now, T is 1 year, so we can just put an R there and solve for R. Get 4,332 is 4,000 plus 4,000 R. Moving back up here, we've got subtracting 4,000 from both sides. You got 332 equals 4,000 R. So divide both sides by 4,000. R equals 332 over 4,000. Convert that to a decimal and then to a percent. And you get about 8.3%. Notice that the effective annual yield will require a higher percentage than with the compound interest. Compound interest gives you more money faster. So if we're using simple interest, you have to have a higher rate to get the same yield. And that is it, folks. We've finished that one, and I hope you picked up a few good things, and I'll see you soon.